Buildings shape the way we live, work, and learn, and they also present one of the greatest opportunities for climate innovation. Nearly 40% of global emissions are connected to the built environment, which means the potential for impact is enormous. The energy use and the materials we choose offer powerful opportunities to reduce embodied carbon before a building even opens its doors. The exciting part is that low carbon alternatives already exist. Today, we'll explore how zero-carbon building materials can transform construction and what it will take to scale these solutions.
Construction technologies and materials have advanced significantly over time. Before the Industrial Revolution, buildings were typically constructed with locally sourced stone, timber, and clay. Then the rise in material manufacturing and global supply chains allowed cities to grow taller and faster than ever before. But those same materials are now among the largest sources of carbon emissions. In other words, most modern construction is designed for speed and scale, not environmental impact. Reducing emissions from building materials isn't just about better products, it requires rethinking an entire system. Zero-carbon building materials cover a range of technology designed to minimize carbon footprint and promote sustainable construction while supporting infrastructure resiliency. These materials typically fit into three groups. Natural materials are sourced with minimal processing or treatments, limiting energy consumption and enhancing biophilic design. Recycled materials are waste materials repurposed into new building products, which reduces natural resource extraction, energy use, and landfill waste. Innovative composites and hybrid materials combine multiple components to boost performance, durability, and sustainability, overcoming the limitations of traditional materials while improving efficiency.
Life cycle assessment measures a product's environmental impacts from raw material extraction, manufacturing, distribution, use, and disposal or recycling. Environmental product declarations take that data and present it in a standardized, verified format that provides a better product comparison. Together, LCA and EPDs can help organizations make data-driven decisions, improve product sustainability, and meet environmental standards. Today, sustainable construction is often shaped by rating systems like LEED. These frameworks set measurable criteria for energy use, water conservation, indoor environmental quality, and low-carbon materials, pushing projects beyond minimum design code requirements.
At ASU and other research institutions, innovation is advancing rapidly, from experimental materials like algae-derived binders to modeling tools that can integrate LCA directly into the design process. Researchers are pushing the boundaries of low-carbon cement by developing alternative materials and manufacturing methods that reduce energy use and reliance on fossil fuels. Researchers are demonstrating that many of these technologies are technically viable and becoming increasingly cost-competitive in certain applications. This highlights an important point. The primary barrier is not technical feasibility, but scaling implementation across supply chains, procurement systems, and policy frameworks.
A new generation of construction technologies is emerging, but most of them are still in their early stages. Technologies like 3D printed buildings can dramatically reduce construction time and material waste, while mass timber offers a renewable alternative that can store carbon instead of emitting it. Automation and robotics are beginning to improve precision and efficiency on job sites. And digital tools like building information modeling are helping teams design and optimize buildings before construction even begins. Despite their potential, these technologies are not yet the industry standard. Low-carbon materials often face barriers like high upfront costs, limited supply chains, risk-averse construction markets, gaps in workforce training, and inconsistent policy incentives. At the same time, zero-carbon building materials can drive innovation, strengthen domestic supply chains, and reduce emissions across the construction lifecycle. Transitioning to low-carbon materials can offer early adopters a competitive advantage and access to projects with stricter environmental standards. Over time, these shifts have the potential to create lasting economic, environmental, and industry-wide benefits.
Policy is one of the most powerful levers for facilitating adoption. When governments lead, particularly through public infrastructure and university construction, they create strong demand signals that bring new technologies to market. By reducing risk for stakeholders, policymakers can make low-carbon materials the industry standard.
To achieve this goal, we should expand lifecycle assessment requirements within building codes, incentivize low carbon procurement practices, strengthen and scale sustainable manufacturing supply chains, invest in research and innovation, and coordinate across the entire construction ecosystem.
Today we have the tools, the data, and the materials to build differently, because every project, every material selection, every design decision is an opportunity to reduce carbon before a building even exists. And the decisions made today will shape the buildings and the climate we live with for decades to come.